G'day everyone! This week I'm continuing with the electrical installation in my bus, and in the next couple of videos I'm going to be showing how I'm doing all the pre-wiring in the bus. So running all the cables to the power points, to the lights, the fans, all of the various things that I'm going to have installed in the bus. I'm not going to be showing the details of how I actually do the connections to those things because that will come in a later video when I actually put the lights and the fans and everything in. For now, I just want to get all the cables run to make sure that they're going to fit where I think they're going to fit, and then I've got enough wire for everything. This video is going to be mostly about the 240 volt side of things, so I'm going to show you the cables that I'm using for that and how I'm running them to the various power points. Now, I'm obviously doing my electrical installation a little bit differently from most people because, I don't know if you can see behind me here, 90% of the interior of my bus is already built. So most people run their wires at the very start of the build before they put the insulation in, before they do the wall and the ceiling linings and so on. I deliberately chose not to do that, and there are a couple of reasons for that. One is that I pretty much made up this whole thing as I went along, and a lot of things got changed from what my original design was when it came time to actually build things. So I wasn't even quite sure at the start where I wanted certain things installed. Like, I wasn't sure where the water pump was going to be. I had a few different ideas. I wasn't exactly sure where I was going to want the power points and so on, or what sort of lights I was going to have. So it didn't make sense to me to run wires to all those things and then end up with wires where you don't want them, or you don't have wires where you need them and so on. So it just made more sense to me to wait until things were built and I was sure where everything was going. But the main reason is that I didn't want my wiring hidden behind walls and inside the roof where I would never be able to access it. I wanted all of my wiring to be fully accessible so that I could periodically check on it to make sure it wasn't getting damaged, that mice weren't chewing on it or anything. And if anything went wrong, I wanted to be able to easily access it all in order to make repairs. So rather than having the wires hidden inside the wall cavities of the bus or inside the roof, I am going to be running mine inside cabinets and inside some of the cavities where I can easily remove the wall cladding to get to the wiring. So it's a little bit different from what you might have seen most people do. It's just the way I've chosen to do it. Just might give you guys another option, different ideas for how you can do things. And this is a learning curve for me as well. So I'm just going to pass on a few little things that I've picked up in my research, things you need to consider when you're doing the wiring for the bus. And I'm just going to share with you guys how I'm doing mine, and hopefully it might be helpful to some of you. Here's my worksite supervisor. Today, I don't think she's feeling very well today. She didn't want to eat dinner last night, and all she wants to do today is eat grass and sleep. So I think she's got a bit of a bellyache. So she's just resting today. Hey, Bubba. Hey, Bubby. Yeah, good girl. For the 240 volt side, so the mains power side of things, I'm actually using the CMS system. So this is a sort of semi-DIY plug and play system where you can buy cables and power points and things that are already pre-wired. So you'll see here I've got one cable. This is, I think, a 2 meter or a 2.5 meter long cable. You can buy them in cut length, so I think they come in like 0.5 meter, 1 meter, 1.5, 2, 2.5, all the way up to I think 5 meters is the longest. And you'll see that each of the cables has 2 plugs on the end. And power points, the CMS power points and everything in this system, you'll see on the back of them have these sockets. And the idea is that the cables basically just plug in to the back of the power point. So it's a very simple system. Everything's already pre-wired. The connections are actually really strong. I won't do it here because once these things are plugged in and they're clicked into place, it's very hard to unclip them again. Now, obviously this is 240 volt. So if you're going to be using this system, even if you do all the connections yourself, you still need a licensed electrician to check it all and do the final sign off. You can buy these cables and the power points that go with them from various online caravan suppliers. Caravans Plus is where I got a couple of things of mine. I also got a lot of my cables direct from my electrician because he was able to order them through his wholesaler, and I was able to get them a little bit cheaper because they are quite expensive. If you are ordering these, it's important to note that there's actually two different kinds of connections. So there's a J system and a C system. I'm using the J series. So you just need to make sure when you're buying them online that you're getting one or the other. So J series cables will only connect to J series power points. The shore power inlet that I put in the side of my bus a couple of weeks ago, had to make sure that was J series because the connections are actually slightly different. And if you try to connect a cable into a power point from the other system, it won't plug in. So just one thing to be careful of, make sure, I think the J series is kind of the most readily available, but just make sure whichever one you're going with that you check before you purchase to make sure it's the right one. I've just put my CMS cables on this table out in the sun just to try and warm them up a bit because they're quite stiff and they wanted to just curl up. So I'm just trying to get them to warm up a bit so that I can straighten them out, and hopefully they'll be easier to run. One thing that you need to keep in mind, and this is something that I wasn't aware of at first until I started doing a bit of research and asking questions about electrical stuff, is that if you're going to have both 240 volt wiring and 12 volt wiring in your bus or your van, then you can't run those wires together. They actually need to be physically separated because you can get problems with interference between the different voltages. So it's actually part of the Australian standard that governs rules about electrical installations, that they must be physically separated. So you definitely can't run them in the same conduit. My understanding is that they need to be separated by at least 50 millimeters. And if that's not possible, then there needs to be some kind of physical barrier between the two. So a non-conductive wall or proper enclosed conduit. So where I've got both kinds of wires running in my overhead cabinets, it's not an issue because, as you can see here, I've got these holes at the top that I can run cables along the top here on the inside of the cabinet, and I also have this cavity underneath the cabinets where I can run wires as well. So one lot of wires can run underneath and the other lot can go inside the cabinet, and they're totally separated. It is an issue up the back here where the wires all have to run pretty much together in order to get across the other side of the bus. So this is my electrical bay here. All of the wiring that's going to be on this side of the bus is going to be crossing over at the very back here. So it all has to come up here. It's got to come along here and down into the small cavity in this corner here underneath the vanity, and to be able to go onto this side of the bus. So now obviously here all of the wires are going to be close together. So in a situation like this, you need to make sure that you're physically separating the wires with proper conduit. Now, my original plan was to use this enclosed conduit to protect the 240 volt cables and this split loom tube to cover the 12 volt wires. And I bought the 32 millimeter size in this conduit thinking that it would be big enough to fit the 240 volt cables, but unfortunately they still don't fit in this. These plugs are about 25 millimeters across. So, you know, I thought the 32 millimeter conduit would be more than big enough, but in actual fact, because the walls of this conduit are so thick, there isn't even 25 millimeters internally here, and I just can't get the plugs into the conduit, which is really frustrating. So I had a chat with my electrician and he said it's fine to do it the other way around. So I'll be using the split loom tube to protect the 240 volt cables, and in the areas where they have to run quite close to the 12 volt wires, I'll be putting the 12 volt wires in this heavier duty conduit, and that will be sufficient to separate the two different voltages. Another thing I've done just to help separate the different voltages in the wiring is this wall here, which is the wall at the end of my table just near the side entry door. You can see I've got a power point installed in this wall, so this is a 240 volt power point. I also want to put a 12 volt USB charging port in this wall as well, and it's obviously going to be quite close to this. So what I've done here inside this wall, I've actually created a divider. So you can see there's like one cavity here where the 240 power point is, and there's another cavity over here that's separated from that, and that's where I'll put my USB charging port. And the wiring will actually be able to be totally separate because the 240 volt wires are going to be running under the cabinet here. So they'll come through, if you can see, they'll be coming through here, through this hole and down to the power point. Whereas the 12 volt wires will all be running through this larger hole at the top of the cabinet and down through there into this cavity. So again, they'll be physically separated, so there shouldn't be a problem with the different voltages being too close together there. That's just something to keep in mind when you're working out where you're actually going to run the wires in the bus. You need to make sure that you've got some way of keeping the two different voltages separate. Right, so the first thing I'm going to do is to cover all of my 240 volt cables with this split loom conduit. There's a bit of a knack to getting this split loom tube over your cables. It took me a while to kind of get the hang of it. The way I find it easiest to do it is to have it positioned so that your cable is on top and the split loom tube is underneath, and that you've got the split of the tube facing upwards, so it's like touching the bottom of the cable. And then as you go, if you bend the split loom tube sort of backwards like that, see how it kind of just easily slips over the cable? That's how I find it the easiest to do it. There may be another trick to it. If you've got another trick to putting this stuff on, let me know. This is what works for me. If you try and sort of do it by sticking your thumb in the gap and pulling it over the cable, it just doesn't work. It's really hard. But if you have it like this, cable on top, split loom tube underneath with the split on the top, and then just bend the split loom tube back like that as you go. Sometimes you have to adjust it a little bit, but you just work your way along like that, and it goes on much easier. So that's it. The other thing that I'm doing, particularly because this is 240 volt cable and I want to make sure it's well and truly protected when I'm passing it through the cavities around the bus, is I'm just going to go along, and any section, I don't know if you'll be able to see this, any section where the split is just a little bit sort of more open and not fully wrapping around the cable, I'm just going to go and put some electrical tape over that just to help keep it well and truly closed over the cable, and to just so there's no little bits of this split loom tube sticking out that could catch on something as I'm passing it through. So I don't know if you can see this one here, there's a little bit of a gap, like the tube's just a little bit more open there. I'm just going to put some tape on that. Okay, so now you can see that that gap's no longer an issue. So I'm going to go ahead and do that with all my 240 volt cables, and then I'll be ready to run those. So I have my rough plan here for the 240 volt cables. This will tell me like which cable goes where. And if you're wondering how I figured out what lengths of cable to get for each thing, I actually used this rope. So I've got an old piece of rope here, and I went around the bus and I physically threaded the rope through exactly where the cables were going to go, and then I marked on the rope. So then I just measured from there to the end of the rope, and I knew exactly what length cable I would need for that. So that's actually how I worked out which cables I had to order. So now I can look at this little rough map and I'll know which cables are going where. Now the way that these CMS cables work is that all of these power points that I have are all on the one circuit. So I think with the CMS system you can have up to 10 or 12 power points in one circuit. So I have 6 here, I think, altogether in the bus. So basically what happens is you start off with the shore power inlet, which is the thing I put in the side of the bus a couple of weeks ago. A cable will run from there up to the breaker box where the electrician's got all the fuses and appropriate connections for this, and then from there it will run to the power points. Now, because I've got power points running on both sides of the bus, I've actually got a double adapter at the very start here, and I'll show you. I've already got that connected. So this is the breaker box that the electrician set up for me. You can see here the AC in, so the 240 volt in. So the cable that I'll install from the shore power inlet to this will be the way that the power comes into the breaker box, and then from there it will come out via this cable. And I'm hoping you can see this on the camera. You can see I've actually got a double adapter plugged into this plug, which means that rather than just one cable plugging into the end of this, I can have 2 cables branching off it. And the idea is that one of those cables will run this way to the power points on the passenger side of the bus. The other cable will run this way around to do the power points on the driver's side. And if I show you the power points, you'll see on the back they actually have 2 sockets. So what happens is the cable comes from, for instance, that first cable will come from the breaker box and it will plug into the first power point on the circuit. And from there, the next cable plugs into here. Actually, I think it's the other way around. But anyway, one of these is the inlet, one is the outlet. So another cable will run from this power point to the next power point, and so on and so forth. Until you get to the last power point on the circuit, it will just have a cable coming in, and this one will be empty, which means that if down the track I want to add more power points, I can just run another cable from that to the next one, and so on. You can get external power points to go on the outside of your bus, and if you get one of those that just has one socket, so that's usually like the last thing on the circuit would be the external power point. I'm not having one of those. I decided I didn't need one because I'll actually be able to access a few of my internal power points from outside the bus if I need to. But anyway, that's basically how the system works. So the first cable I'm going to run is the one from the shore power inlet up to the breaker box, and I look at my plan here and I can see that that's a 2.5 meter cable that I need for that. So I'm finished running all the 240 volt cables, so let me show you how I've got mine set up. Alright, so I'll start here in the back of the bus because this is where my shore power inlet is. So this is where I would plug the bus into power if I was at a caravan park or somewhere. So I have a cable here that will plug into that, and it's running down under the wall here, up through behind this wall here, and it's coming out here. And you can see I've labelled it shore power so I know which one's which. It will plug into this cable here, which will bring the AC power into the breaker box, and then from there it will come out this cable here that has the double adapter, and it will connect to these 2. So one will go through here along the back of the wall, and you can see it going up there and down here to this power point. So I'm going to have a power point here in the kitchen. This part of the pantry wall, once I've done all the wiring and the electrician signed everything off, this will actually have a back on it, so you won't see any of the cables in the back there. And then from the power point here, the cable runs up under the cabinets here to and into this wall, down to this power point here that I have near my table. So this PowerPoint I'll be able to use when I'm using the computer, my printer and sewing machine and so on at this table. That's the PowerPoint for that. So if we come back here to the breaker box, so from that double adapter, I'll also have this cable here that runs through this wall inside what will be the floor of this upper cabinet here, down into the wall here to this PowerPoint, which will be for my washing machine. And from there it runs back up into the wall here and to this cable here, all the way along the back of the bus here and down through down the corner and into this, behind this wall under the vanity, to this PowerPoint here where I'll be able to plug my fridge in. And then from there there'll be this cable that runs behind my fridge. Sorry, it's a bit awkward in this space. It's running behind my fridge, and you can see it's coming out there, and it's actually, I don't know if you can see this very well, but it's actually running along, if I come back here I might be able to explain it better. So this is the cabinet under my kitchen sink, and I have this little area in front of the wheel arch here that has a door on it that comes off as well, and the cable is running up under there through a hole in this floor and up into here where this PowerPoint is. This is the PowerPoint for my hot water system, and from there it runs. This will actually be inside the wall because I'll be putting cladding over the top of this. It'll run up through a hole in this shelf here, and you can see it's going inside this cabinet, up through a hole in the back of the cabinet there. And from there it runs behind this wall to come out here for the PowerPoint that will be here in the kitchen. Now obviously I don't have any of those cables connected to the PowerPoints. I will be getting the electrician to do that and just double check everything before he signs it off. And then once he's done that, I'll be able to finish off the wall cladding to hide the rest of the cables, so you won't really see any of that. I also need to finish securing this cable that runs along the floor here behind the fridge. In order to do that, I need to get this fridge out of the way, so I'm just waiting until I'm ready, because I'll also have some 12-volt cables and plumbing and some other things behind this fridge. So I'm going to do as much as I can with the fridge in place, and then I'll be getting the fridge out of the way to finish tidying up the wiring that's going to be behind it. So that's pretty much all I can do for the 240 volt side of things until I see the electrician. Hopefully what I've done is okay. And my next job is to run all of the 12 volt wiring, and that'll be in the next video.